Welcome to the class. So this is part 2 of Laplace transforms. So I'm doing a series of lectures on Laplace transform where I'll be discussing some basics followed by the previous year questions. So we'll be solving previous year questions along with some revision of the basics of Laplace transform. Right. In this second part also we'll continue our discussion of Laplace transform of some signals. Right, wherever necessary, I'll give you some basics. And in this class, we are also going to find Laplace transform of some signals which look like periodic signals only for positive time. Okay, right then. So let us start our class. Right. So here they have given a signal. So just to confuse us, they have given some signal which is looking a little complicated, but that's not a complicated signal actually. So they have given e power a plus 2t plus 5, which can be written as e to the power of a plus 2 into t into e to the power of 5. E power 5 is just a constant, okay? Now, the signal, you know how the signal looks like. It is e power a plus 2 into t into e power 5. Now, in what range? Real part of s, which means ROC they're talking about, should remain so that the Laplace transform of the function exists. So, for this function as it is, Laplace transform does not exist. For example, I'll just take an example, okay? For example, e power at into u of t. Let me take an example, okay? The Laplace transform is 1 divided by s minus a. And the ROC is a real part of s greater than a real part of a. Because it is a right-sided signal. For all right-sided signals, ROC is real part of s greater than real part of the pole. Here the pole is a. Whatever is in the power apart from time, that is the pole. Right? Or you can observe from the Laplace transform. The pole is when the denominator, the value of s at which the denominator becomes 0, and that is s equal to a. That pole you can recognize in the time domain signal itself. Right? So if the same signal e power at is given with u of minus t, the Laplace transform is, or with an extra minus also you can take. So without that extra minus, it will be minus 1 divided by s minus a. Instead of u of t, if you are having u of minus t, so the same answer you are getting, but extra minus sign. And one more thing is ROC will be, for left-sided signals, ROC also will be left-sided. So it will be real part of s less than a real part of the pole. The pole here is again a. So this is the ROC. So what if they have given us e power at? If they have given us e power at, we can only write it as e to the power of at into 1, which can also be written as e power at into 1 can be written as u of t plus u of minus t, u of t plus u of minus t. Now let us find the Laplace transform of this one. If you find the Laplace transform of this one, it is 1 divided by s minus t is the answer for this. And the answer for e power at into u of minus t is minus 1 divided by s minus a. The ROC for this part is a real part of s greater than a real part of a. And the ROC for this one is a real part of s less than real part of a. What are the common values, can you tell me? Real part of s greater than real part of a, real part of s less than real part of a, there is no intersection. So which means there is no common value of real part of s for which the Laplace transform of the first signal e power at into u of t and e power at into u of minus t, both of them does not exist. The Laplace transform of both the signals does not exist even for single value of real part of s. So the ROC, there is no intersection. So that's why this Laplace transform does not exist. You should not write it as 1 by s minus a plus 1 by minus 1 by s minus a also. Don't say that it is 0. 0 means it's defined only. It's not even 0, it does not exist. Because there is no common value of, there is no common ROC for which Laplace transform of these two individual signals will exist. Individually, they are having, both are having Laplace transforms. Individually, both are having Laplace transforms. But just e power at means, let's say you can look at e power at as e power at into u of t plus e power at into u of minus t. This signal has an ROC like this, and the second signal has an ROC. You can look at in the second signal. These two ROCs does not have not even one value intersection. So there is no common value of sigma or real part of s for which Laplace transform of both signals exists. So that's why e power at Without u of t or without u of minus t, if you write, Laplace transform does not exist. Or we can generalize also. Power signals or neither energy nor power signals. Power signals are neither energy nor power signals which exist from minus infinity to plus infinity. The signals which exist from 0 to infinity, fine. From minus infinity to 0 is also fine. But the power signals or neither energy nor power signals which exist from minus infinity to plus infinity does not have a valid Laplace transform. Does not have a Laplace transform. Does not have a Laplace transform. Okay, right. Now coming back to the original question, we have learned some interesting points here. Power signals or neither energy nor power signals which exist from minus infinity to plus infinity does not have a valid Laplace transform. Okay, I'm not sure if you are able to see this. Yeah. Does not have a valid or just Laplace transform. Does not have a Laplace transform. LT means Laplace transform. Right here, they did not give us u of t or u of minus t. So if they don't give any time, if they don't give u of t or u of minus t, then you have to assume that u of t is there, because by default our assumption is it's a causal signal. If at all if the information is not given, they did not ask us whether the Laplace transform exists or not. They are saying it exists for some ROC, and what is that ROC they are asking, which means they are assuming that it is one of these two signals, either u of t is there or u of minus t is there. But whenever they don't give whether it is u of t or u of minus t, by default we can assume that it is a causal signal. Though they have not given u of t, you can assume that u of t is there, because without u of t, Laplace transform does not exist. There is no common ROC also. But they are saying some common ROC should be there. What is that common ROC? For which the Laplace transform exists. So we can assume u of t is there whenever it is not given. Okay, based on the problem you have to take. So if they ask you Laplace transform of this signal exactly, then you cannot assume u of t, because the point they're not we should not assume, because if they're asking only the Laplace transform of this signal, it does not exist. We should not assume. Okay, right here they're saying ROC is existing and they're talking about this signal, so that's why we can assume that u of t is there. Because if you don't assume u of t or u of minus t, then Laplace transform will not exist. Then we cannot say some ROC, because if you see the options, every option is having some non-zero ROC. Okay, some ROC is present, which means there should be either u of t or u of minus t. When there is a confusion whether you have to take u of t or u of minus t, by default you can take u of t. By default our assumption about signals are causal signals, default assumption. But if they specifically mention it is a non-causal signal, then you have to take it like that only. Right, now tell me this one. So the Laplace transform of this signal is very simple question. The constant is e power 5. If constant is multiplied in time domain, same constant is multiplied in Laplace also. So e power 5 into Laplace transform of this signal is 1 divided by s minus of a plus 2. A plus 2 is the pole here, and the ROC is, as we have discussed previously, since it is right-sided signal, ROC is real part of s greater than real part of the pole. So ROC is real part of s greater than real part of the pole, which is a plus 2. This is the exact answer, but they did not give real part of a plus 2. Maybe their assumption might be a might be real. If a is real, then you can remove this real part and you can simply write it as a plus 2. This is the perfect answer, more appropriate answer you can say. But in the options, if you see, this is the only option that we are having which is matching. Okay, right. So let's move on to the next question. We have discussed some really interesting points in this slide. This is one point which you can apply for any power signal, any neither engine or power signal which exists from minus infinity to plus infinity. It does not have a Laplace transform. Okay, if you want, I can take some examples. So if it is e power 5t, 5 mod t, if you take this one, so Laplace transform of this signal does not exist because it is two-sided, neither energy nor power signal. Next up, constant signal 1. Laplace transform does not exist because it is a two-sided power signal. Next up, cos omega naught t. Bilateral Laplace transform. But our discussion is about bilateral Laplace transform. You have to mind this. So cos omega naught t bilateral Laplace transform does not exist because this is a power signal from minus infinity to plus infinity. You might have remembered a formula for cos omega naught t. Yeah, I agree that you remember the formula for cos omega naught t. So excuse me for this because my video should be blocking what I'm writing here. I'll write the same thing in the next slide. Okay. One, Laplace transform, bilateral Laplace transform does not exist. Okay, and e power 5 mod t. It's a two-sided neither energy nor power signal. Bilateral Laplace transform of this signal also does not exist. As I've made whatever statement I made in the previous slide, you can use that statement. And cos omega naught t. Don't say unilateral Laplace transform. Bilateral Laplace transform does not exist. Sin omega naught t. Bilateral Laplace transform does not exist. Okay, but we know some formula about cos and sine. We'll write that. Cos omega naught t bilateral Laplace transform does not exist, but if u of t is multiplied, then we know the bilateral Laplace transform. Cos omega naught t into u of t bilateral Laplace transform is s divided by s square plus omega naught square. I have derived this in the previous part 1 also, part 1. Similarly, sin omega naught t into u of t also we know bilateral Laplace transform. If u of t is there, then we know it. It is omega naught by s square plus omega naught square. Next, similarly, if u of t is replaced with the u of minus t, same bilateral Laplace transform, but minus sign will be there extra. The ROC here, in the first case, ROC is a real part of s greater than real part of the poles. The poles are minus j omega naught and plus j omega naught. So real part of the poles is 0. In the second case also, same ROC, real part of s greater than 0. Real part of s greater than 0. For this case also, ROC is real part of s greater than 0. Next one. So for this one, since there is a left-sided signal, ROC is real part of s less than real part of the poles. The poles here are plus j omega naught and minus j omega naught, so it is less than 0. Similarly, sin omega naught t into u of minus t also we can write. So bilateral Laplace transform of this signal is minus omega naught. Whenever there is u of minus t, it will be same Laplace transform. Laplace transform function will be same, but minus extra sign, extra minus sign will be there, and ROC also will change. ROC will be real part of s less than 0, right? And you might have learned in mathematics, whatever Laplace transform we learned in mathematics is unilateral Laplace transform. I'll discuss about unilateral Laplace transform also maybe in part 4 or part 5 of Laplace transform. There you'll get more and better understanding of unilateral Laplace transform. But here I'll write cos omega naught t. Cos omega naught t unilateral Laplace transform is definitely s by s square plus omega naught square. When we are talking about unilateral Laplace transform, we don't mention any ROC. Whereas when we are talking about bilateral Laplace transform, we mention ROC. Similarly, sin omega naught t, for sin omega naught t also, unilateral Laplace transform is omega naught by s square plus omega naught square. Okay, I'll explain very clearly what is the difference between unilateral Laplace transform and bilateral Laplace transform in further parts. In this series of lectures only. In further classes, I'll be discussing about unilateral Laplace transform as well. Fine. So let us move on to the next question. So this question is over. So in this question, they're talking about Laplace transform of unit ramp function starting at t equal to a. So unit ramp function starting at t equal to a. So let me first plot it. We know how a ramp function looks like, but they are talking about a ramp function which is starting from a as a function of t. So ramp function starting at a, we can write the equation as r of t minus c. It is looking like ramp function which is starting at 0 shifted by a units. It is looking like that. So we can write it as r of t minus a Fine. So they're asking about the Laplace transform of ramp function. First, let us write the Laplace transform of R of t. Bilateral Laplace transform is 1 by s square. U of t Laplace transform also we know, which is 1 by s. ROC is real part of s greater than real part of the pole. The pole here is 0. You can imagine this here as e power 0 into t, or here also you can understand from the denominator. When s equal to 0, the denominator becomes 0. The value of s at which denominator becomes 0, or the total Laplace transform function becomes infinity, is what we call as pole. Here the pole is s equal to 0. So real part of s greater than a real part of the pole whenever you are talking about right-sided signals. Similarly, for left-sided signals, it will be real part of s less than a real part of the poles. And for R of t also, the poles are s equal to 0 only. So ROC will be a real part of s greater than a real part of the pole. Next, now they are asking us to find out R of t minus a Laplace transform. So we have to use a time shifting property, which I have discussed in the previous class. So R of t minus a Laplace transform is, we can use time shifting property. It is e power minus as divided by s square. So ROC is a real part of s greater than 0. Is that correct? Or any change in the ROC? Look at this one. So e power minus as, e power minus as. So if s equal to minus infinity, then minus into minus is plus infinity. If a is positive, then s equal to minus infinity, the Laplace transform is becoming infinity. So s equal to minus infinity should not be part of the ROC. It is already not part of the ROC. Okay, R of t also does not have minus infinity as part of the ROC. So ROC should not change if a is positive. What if a is negative? This is the ROC if a is positive. If a is negative, what happens? If a is negative, then negative into negative is positive. If s is equal to plus infinity, this total thing is becoming infinity. For whatever value of s, the Laplace transform becomes infinity. We can call that as pole. So now the new pole has become s equal to 0 is already a pole. S equal to plus infinity will become a pole when a is negative. Because when a is negative, negative into negative becomes positive. When s equal to plus infinity, e power infinity becomes infinity. So s equal to infinity becomes pole, and ROC should not include the poles. So the ROC becomes 0 less than a real part of s less than infinity. A small change in the ROC. Earlier it was from 0 to infinity, infinity also included. And here it is from 0 to infinity, infinity not included. A small difference. A small change in the ROC, even if you don't observe this also, it's okay. Generally in this kind of problems, they don't test you on this very, very simple change, but this is also very crucial observation. Okay. So this is the change in the ROC for if A is negative. Okay, fine. So let us move on. So I've explained this when I'm discussing about time shifting property as well, this basic stuff. Right. So here in this problem, they are testing us on some property of Laplace transform itself. So first let me give you the property. If there are two signals, x1 of t, whose Laplace transform is capital X1 of s, and the ROC is, let's say, R1, and x2 of t is the second signal whose Laplace transform is x2 of s, whose ROC is R2. When I'm writing ROC, it is bilateral Laplace transform only. In signals course, generally we'll talk about only bilateral Laplace transform, whereas in mathematics, they don't mention it as unilateral or bilateral. When mathematics, you'll be dealing with unilateral Laplace transform. So when two signals are convolved in time domain, what happens in Laplace is the corresponding Laplace transforms, Laplace transform of x1 of t and Laplace transform of x2 of t, they get multiplied. And what happens to the ROC? ROC becomes intersection of individual ROCs, because the poles in x1 of s and poles in x2 of s both are present in this final Laplace transform. So when the pole pattern changes, whenever the pole pattern changes because of any property, whenever pole pattern changes, ROC changes. Okay, that's the thumb rule. Whenever the poles changes, definitely ROC should change, right? Because ROC should not include poles. When number of poles increases or decreases, ROC should change, right? ROC, and we cannot say that it should 100% change. It may change. Okay, after R1 intersection R2, might be same as R1 or might be same as R2. Okay, so when you compare with R1, it may not change or it may change, we don't know, right? But it is finally R1 intersection R2. This is the simplest way of understanding it. So when due to some property, if the pole pattern changes, then ROC might change. I'm not 100% sure that it will change. It might change or it may not change. Right, here they are testing us on the same basic here. So h of t, if you observe, so this is, if you look at this one, they are talking about convolution formula only, but the basic convolution formula that we know should be starting from minus infinity. Actually, it should be from minus infinity to plus t. That is the basic convolution formula. It looks exactly like convolution formula, but lower limit is not, should not be 0 in the convolution formula, it should be minus infinity. But if f of t is a causal signal, then we can definitely assume that if f of t is causal, then it exists only for a positive time. So then we can write it as 0 to t. Actually, it should be from minus infinity to t, assuming f of t is causal. One second. First, let me write the basic convolution formula. Then it will be for you easy to understand. So, what if x1 of t is convolved with x2 of t? The formula will be integration from minus infinity to plus infinity. In the convolution formula, upper and lower limit are minus infinity and plus infinity. x1 of tau into x2 of t minus tau beta. Okay. So this is the actual formula. If x1 of t is causal, if this is causal, then what happens to the formula is it becomes 0 to infinity. When x1 of t is causal, the formula changes like this. This is the formula if first signal x1 of t is causal. Causal means it exists only for positive time. It exists from 0 to infinity. So then this is equal to integration from 0 to t x1 of tau into x2 of t minus tau will be the formula if, this is the formula if both signals, if x1 of t and x2 of t both are causal. The convolution formula changes based on whether one of the signals is causal or both the signals are causal. Okay. What if x2 of t is causal? Let me write the formula. If x2 of t is causal, lower limit will not change, only upper limit will change. x1 of tau into x2 of t minus tau beta. If x2 of t is causal, so upper limit will change like this. This is the formula if x1 of t, x2 of t is causal. So this is the actual formula, and the formula we can change the limits. In this way whenever one of the signals is causal or both the signals are causal. Okay, right here. Since no other extra information is given, so we have to assume, because this is looking like convolution formula, lower limit and upper limit both are changed. Since lower limit and upper limit both are changed, we have to understand that okay, they might be assuming that f of t and g of t are causal. That information is not given, but we can assume. Okay, so if you assume that, then what we can write is h of t can be written as, if you look at the formula and compare with this formula, 0 to t, it is f of t convolution with g of t. It looks like this. Instead of giving like this, they are giving us a formula just to confuse us. Now once you figure out that h of t is f of t convolution with g of t, how about Laplace transform of h of t? Laplace transform of h of t is Laplace transform of this signal f of t convolution with g of t, whose Laplace transform will be Laplace transform of f of t, convolution becomes multiplication into Laplace transform of g of t. So multiply Laplace transform of f of t and g of t. If you multiply these two, then what happens is s plus 2 gets cancelled, and s square plus 1 and s square plus 1 gets cancelled. The remaining part is very simple, it is 1 by s plus 3. So they're convolving the signals in time domain. What happens in Laplace domain? The Laplace transforms gets multiplied, and the Laplace transforms are given in such a manner that the numerators and some some terms are getting cancelled, and finally it is ending up in a very simple term 1 by s plus 3. So this is the Laplace transform. Here we have discussed convolution property in time. Convolution in time property of Laplace transform. Using this property we can solve this problem very easily. Fine. So let us move on to the next question. Right, next question. So to solve this question, two things we should know. One is Laplace transform of cos omega naught t into u of t we should know, and we already have discussed that in previous class, and I've revised this in present class also. So if you remember, this is the Laplace transform of cos omega naught t into u of t. So let us write that first. Cos omega naught t into u of t. Laplace transform, bilateral Laplace transform is s divided by s square plus omega naught square. Now in this case they are not giving cos omega naught t, instead they are giving cos alpha t into u of t, which is equal to s divided by s square plus alpha square. Instead of omega naught we are having alpha. This is the Laplace transform of cos alpha t into u of t, but they are not asking about cos alpha t into u of t, they are asking about e power alpha t into cos alpha t into u of t. Now here we need to learn one property which will help us do this problem very easily. Let me recollect that property here. If x of t has a Laplace transform of x of s, where the ROC is a real part of s, something greater than or less than something, we don't know because signal is not given. We cannot say what exactly is the ROC, but for the sake of conveying how the ROC changes because of the property, I am writing it as real part of s. Now if x of t is multiplied with e power at, let me write the general property here. E power at into x of t, Laplace transform will be x of s minus a. If you know the Laplace transform of a signal, and if that signal is multiplied with some exponential signal, then you can find the Laplace transform very easily. The same Laplace transform, but replace s with s minus c if you are multiplying with e power at. So this is similar to frequency shifting property of Fourier transform. So in time shifting property, the sign here and sign here will be same. Okay, and in frequency shifting property or in s shifting property, this is what we call as s shifting property. We call it as s shifting property. So in s shifting property, similar to frequency shifting property, the sign will be opposite, reverse. Here it is a plus and here it is a minus. Similarly, let us write the other way also. E power minus at into u of t. Then here it should be same Laplace transform, s replaced with s plus a. ROC also, in the ROC also replace s with s plus a, which means ROC is perfectly changing. ROC will change because s is replaced with some other value, so the pole's location will change. So ROC should be changing. Right, now let us do this problem. So now they are asking us to find Laplace transform of e power alpha t, e to the power of alpha t into cos alpha t into u of t, whose Laplace transform is, we already know the Laplace transform of this part. This is the Laplace transform. When you multiply with e power at, what happens? S is replaced with s minus a. S is replaced with s minus a everywhere. So it is s minus alpha divided by s minus alpha whole square plus alpha square. Okay, this is the Laplace transform. But we should be talking about ROC. In the options, they are not talking about ROC. So for this problem, we don't need to talk about ROC. We can mark the answer. But anyway, learning about ROC is the most crucial part. So what is the ROC of this signal? Cos omega naught t into u of t. Into u of t is there, so right-sided signal. For always right-sided signals, ROC will be real part of s greater than real part of the poles. So the poles are here plus j omega naught and minus j omega naught, whose real part is 0. So real part of s greater than real part of the poles, which is 0. Next, second part, same thing only. Same signal, real part of s greater than real part of the poles, which is 0. For cos and sine signals, poles are on the imaginary axis, j omega axis or on sigma equal to 0 line. So the real part of the poles of cos and sine are 0. Real part of cos and sine signals are zeros. Right. So next, so what is happening now? Because of multiplication with e power at, what happens? S is replaced with s minus a in the ROC also. What is happening to the ROC? Real part of whatever is the ROC earlier, so in that s is replaced with s minus alpha. S minus alpha greater than 0. So what is happening to the ROC now? Send alpha onto the other side. Real part of s greater than a real part of alpha, which we can write as alpha, because alpha is real. Because cos alpha t they are rating, which means definitely the angular frequency is real number. So this alpha should be also real number. Okay, because here in this case we clearly know alpha should be a real number because it is inside cos. Alpha is behaving like angular frequency. Angular frequency should be real only, right? Right. So alpha, we know that alpha is real. So instead of writing as real part of s greater than real part of alpha, I'm writing it as simply alpha, because real part of alpha is same as alpha because alpha is real. So this is the exact answer. They did not mention arboses, but we have learned about arboses as well. Fine. So let us move on to the next question. Right. So they're talking about periodic functions. So in this question, we are dealing with periodic functions. The next 2-3 problems also are based on the same funda. Fine. So let us discuss this problem first, and then we'll move on to this type of questions. These are all similar type of question. So once I discuss about one problem, you'll be able to understand and do all the remaining problems as well. So first let us complete this question. Right. So this is the question. X of t is equal to s of t plus s of minus t. X of t is equal to s of t plus s of minus t. Okay. Now we are given s of what is s of t? S of t is given as beta times e power minus 4t into u of t plus beta times e power plus 4t into u of minus t. Okay. Now let us take the Laplace transform on both sides. So if you take Laplace transform on both sides, x of s is equal to beta times Laplace transform of e power minus 4t is s by s plus 4, and the ROC of this term is real part of s greater than minus 4 plus beta times the Laplace transform of e power 4t into u of minus t is minus 1 by s minus 4. Instead of u of t, if you are having u of minus t, there will be an extra minus sign. And the ROC of the second part is the real part of s less than 4, because left-sided signal ROC will be left side of the pole. Real part of s less than real part of the pole 4. Real part of 4 is 4 only. Right. So is there any intersection between the ROCs? Yes, there is intersection between the ROCs. So this corresponds to values from minus 4 to infinity. This corresponds to values from minus infinity to 4. So the intersection of these values is minus 4 less than real part of s less than 4. So this is the common ROC. Since common ROC is there, Laplace transform will exist. And it is given that Laplace transform exists, and the ROC they have given is also matching with what we have done. Yes, perfect. Now let us simplify this further. So in the denominator it is s minus 4 into s plus 4 into s minus 4 is s square minus 4 square. In the numerator it is, sorry, I have written a mistake here. It's not s here, it is 1 only now. E power minus 4t into u of t Laplace transform is 1 by s plus 4, 1 by s plus 4. Right. So it is beta, let us put it outside. And what remains is s minus 4 minus of s plus 4. Yes, and s cancelled. So this is equal to minus 4 plus minus 4 is minus 8. Minus 8 times beta divided by s square minus 4 square. ROC is minus 4 less than a real part of s less than 4. Now compare this with this one. X of s, we got this, and they have given it as 16 by s square minus 16. Yes, here instead of 4 square we can replace it with 16. So minus 8 beta should be equal to 16. If you want minus 8 beta to be equal to 16, how much should be beta value? Beta value should have been minus 2. So the answer is minus 2. Okay. It's a simple question. But here, you can assume that time reversal property is being used, or if you replace, if you find s of minus t, then without using time reversal property, if you know how to find the Laplace transform of this signal, then without using time reversal property also we can do the problem. Fine. Right, very good. So we have covered most of the problems based on finding Laplace transforms. Okay. Now we'll deal one model of one more different model of problems on Laplace transform, which is Laplace transform of function, which is periodic only for positive time. Basically, if you're talking about periodic signals, they should be periodic from minus infinity to plus infinity. But for a signal which is periodic from minus infinity to plus infinity, Laplace transform does not exist, because as I told you in the previous slides we have discussed, let me show you that slide. Yeah, power signals and neither energy nor power signals which exist from minus infinity to plus infinity does not have a Laplace transform. Because why will it not have a Laplace transform? Because it will not have a common ROC. Because left-sided signal will have a left-sided ROC, right-sided signal will have right-sided ROC. There need not have a common ROC. So power signals will have Laplace transform if they exist only for positive time, or they start from a point and go till infinity, or they start from a point and go till minus infinity. Definitely Laplace transform will exist. But power signals or neither energy nor power signals which exist from minus infinity to plus infinity, they don't have a Laplace transform. You have to mind this. You have to understand this carefully. And I've taken some examples also here. So from these examples you can get more clarity, right? So you should understand the Laplace transform of a function f of t into u of t, where f of t is periodic. Periodic means it exists from minus infinity to plus infinity. For f of t, Laplace transform, bilateral Laplace transform does not exist, because it is periodic signal, which means it exists from minus infinity to plus infinity, and it is a power signal. Generally periodic signals are power signals. Not all periodic signals are power signals, but some periodic signals are power signals, right? So but f of t into u of t will have, once you multiply with u of t, what happens is this periodic signal exists only for positive time. It's a causal signal, but repetition is happening, but only happening for positive time. So f of t you can call it as periodic signal, but f of t into u of t, according to the definition of periodic signal, it is not periodic. We cannot call it as a periodic signal, because periodic signal means it should be repeating from minus infinity to plus infinity, right? So this is not a periodic signal, but it is repeating only for positive time. Fine. For this kind of signal, Laplace transform exists. And how is the Laplace transform? For any periodic signal, you can follow the same procedure. You can take any shape, okay? You can take any shape is fine. So some shape should be repeating. Let me take a triangular shape, okay? And so on, as a function of time. So let me say this is f of t into u of t, okay? So let me say this is t, this is capital T, this is 0. This signal is repeating after every t seconds. I'll just tell you a simple technique to solve this kind of questions. Fine. So let us assume this is some x of t, and this is some x of t minus capital T. Because x of t shifted by t units, we get x of t minus capital T. And this signal we can look at it as x of t minus 2 times capital T, and so on. Like this, infinite repetitions are there, like that infinite x of t terms are there. Right. So can we express this signal? Can we express this total signal as x of t plus x of t minus t plus x of t minus 2t plus x of t minus 3t minus 4t, and so on, like this. Now if you find the Laplace transform of f of t into f of t is a periodic signal. If you multiply with the u of t, it becomes only periodic only for positive time. So we should not call it as periodic signal, but it is repeating for positive time. So if you find the Laplace transform of x of t, it is x of s plus Laplace transform of x of t minus t is e power minus st into x of s, plus next one Laplace transform is e power minus 2st into capital X of s, plus and so on. So if you take x of s common, what remains is 1 plus e power minus st plus e power minus 2st, and so on. Okay. So it is 1 plus e power minus s capital T plus e power minus 2 s capital T plus and so on. It is looking like geometric progression. So it is x of s into Laplace transform, it is infinite summation of infinite GP, which we can write as a by 1 minus r 1 divided by 1 minus e power minus st. Look at this one. So the Laplace transform of this signal is x of s into 1 divided by 1 minus e power minus s capital T. This capital T is nothing but the time after which it is repeating in the positive time, right? So Laplace transform of function f of t into u of t, where f of t is periodic with period capital T, is a of s. A of s times the Laplace transform of its first period. In the first period, this is the x of t signal. Laplace x of s is the Laplace transform of the first period. In the first repetition, whatever signal is there, that signal's Laplace transform, if you know, then it is as good as knowing the Laplace transform of the total signal also. If you know the Laplace transform of the first signal, Laplace transform of the first signal or signal in the first period multiplied with 1 divided by 1 minus e power minus s into the periodic repetition, the time after which it is repeating, you can substitute that and you can then get the Laplace transform of this complicated signal. Though it's looking complicated, the Laplace transform is very, very simple. You can use this basic for any signal which repeats in the positive time, right? So if a of s times the Laplace transform of its first period, what is a of s they're asking? So a of s times the Laplace transform of its first period. Laplace transform of its first period in this case is x of s. In this case they are taking it as a of s. It's multiplied with how, what? A of s is the a of s times Laplace transform of its first period. Laplace transform of first period is x of s. It's multiplied with 1 by 1 minus e power minus st. In this case they are assuming a of s as 1 by 1 minus e power minus st. So a of s is nothing but 1 by 1 minus e power minus st. Okay, fine. This is a standard question. Okay, so in the next two questions that we are going to deal with are, in this case, in this problem I have dealt with a general case. In the next two questions they're going to give you specific data, like instead of t they'll give you some number. Then you can use the same basic to find it. Let us do that. Fine, let us try this problem. Okay, so here also it is signal is periodic only with the positive time. It's causal signal. We should not call it as periodic signal according to the definition of periodic signals, but it is repeating for positive signals. So signal in the first period, let us call it as x of t, and this will be x of t minus t. You don't need to remember that formula also, you can do it directly. X of t minus 2t and so on. See this one, x of t, if you shift this by t units, capital T units, we get this and so on. So f of t can be written as x of t plus x of t minus t plus x of t minus 2t and plus and so on. So if you find Laplace transform of f of t, Laplace transform of f of t is equal to x of s plus e power minus st into x of s plus e power minus 2st into capital X of s plus and so on. X of s, if you take common, what remains is looking like sum of infinite GP, which is equal to 1 by 1 a by 1 minus r. In this case, rate of progression is e power minus st. Okay, right. So this is the Laplace transform. Now, in this case, x of s is the Laplace transform of the first signal. So let us write what is x of t here, and then we can find x of s. X of t is looking like a rectangle from 0 to t by 2, which we can express it as u of t minus capital T by 2. Okay, so now x of s is equal to Laplace transform of u of t is 1 by s minus Laplace transform of u of t minus t by 2. By using time shifting property, it is e power minus s t naught. In place of t naught, we are having t by 2 divided by s, which is equal to 1 minus e power minus st by 2 divided by s. Fine. In this case, capital X of s is the Laplace transform of the signal in the first repetition or first period, which is 1 minus e power minus st by 2 divided by s. This is the Laplace transform of x of s. What else is remaining? 1 by 1 minus e power minus st. Now, if you look at this one, if you look at the numerator, it is looking like 1 minus a, and the denominator, if you observe, this is, if this is 1 minus a, this is like 1 minus a square. So we can express it as 1 minus e power minus st by 2 into 1 plus e power minus st by 2. Look at this one. It is looking like 1 minus a into 1 plus a. If this is looking like 1 minus a, this is, the denominator can be written, look at it as 1 minus a square. Whatever is the value here, that square of that value is here. So if this is 1 minus a square, we can write as 1 minus a into 1 plus a. So numerator and denominator gets cancelled. What remains is 1 divided by s into 1 plus e power minus st by 2. There is some cancellation as well in this problem. Not always. In every problem, there need not be cancellation. In this case, it is happening. So the answer is 1 divided 1 by s is also there, right? S is also there. 1 minus e power 1 plus e power minus st by 2. So I think there is a minus missing here. This should be the closest option. There should be some typing mistake. There should be a minus here. Here s is not there. S is not there. That s is missing. Here s is there, but minus is missing here. Fine. This should be the answer. Fine. Let us move on to the next question. So this is also a problem based on the same concept that we have discussed just now. So signal which is repeating only for positive time. Causal signal, periodic signal, but existing only for positive time. By definition, it is not periodic, but it is repeating. So let us assume this as x of t. Then this will be x of t minus t. If you want to remember the form also, no problem. Okay. So this is from 0 to 2 pi, and so if you shift the signal by 2 pi, then we get this signal. So x of t minus 2 pi. This is x of t minus 3, t minus 4 pi, and so on. Or you can use the general formula also, no problem. So f of t can be written as x of t plus, in this case, capital T is 2 pi here, and so on. So f of s, if you take Laplace transform, it will be x of s plus e power minus 2 pi s into x of s plus e power minus 4 pi s into x of s, and so on, which is equal to x of s into, the remaining term is looking like a sum of infinite GP, which is 1 by 1 minus e power minus 2 pi s. So yeah, we got the answer almost, but not exactly. So the function they have given us, f of t function, they have given us a sine t. Yes, it is looking like sine function only. Even if they have not given this also, we should be able to figure out. Okay, so in this case, they are making our job easy by giving the function, but they, without giving the function also, they can ask the same question. Without this part also, we can do the question in the same manner. So if you look at this question, it is looking like sine function, only the negative cycles they are taking. Only the negative cycles if you take. So this function is looking similar to this, not exactly same, but similar. So they have not given the height, no. So let us take it as minus 1 and plus 1, since they have not given. And this value they are saying it is pi, 2 pi, 3 pi, 4 pi, and so on, right? So what would be the signal? The time period of the signal. Time period of the signal is 2 pi. Time period, let me say, yeah, time period is 2 pi. So this implies omega naught. Angular frequency is 2 pi by t, which is equal to 2 pi by 2 pi, which is equal to 1. So angular frequency is omega naught, and this looks like sine signal. So it is sine omega naught into t. Omega naught is 1, it is sine t. But if it is sine t, it should exist for negative time also, but it is existing only for positive time. It is existing only for positive time. So if you want to write this signal, this is sine t into u of t. Okay, but whatever you are looking at here, so if you know the Laplace transform of the first period, then you can find the Laplace transform of this total signal also, right? So Laplace transform of only this part. How about x of t? X of t can be written as, so, or else, instead of writing it as sine t into u of t, we can also write it as sine t. If you can extend it for negative time also. If you can extend it for negative time, then we can simply write it as sine t. Now this sine t only we want, but we want it only from pi to 2 pi. So if you want to limit any signal from any point to any point, you can take the help of subtraction of step signals, or you can use rectangular functions. If you multiply this signal with the rectangle which exists only from pi to 2 pi, then you get only this signal, only this signal. We are not interested in all the terms, okay, all the signals, in all those repetitions. We are interested only in the first repetition. If you can find the Laplace transform of the first repetition, then we can find the Laplace transform of all the repetitions as well. So our target is, if you can express the equation of the first repetition, then we can find the Laplace transform. If you can write the equation in a familiar format, right? That is what I'm trying to do. So we can write the equation of this signal as, it is looking exactly like sine signal, only this part, only this part. We want only this part. So multiply this total sine t signal with the u of t minus pi minus u of t minus 2 pi. You can multiply with this. So this is the signal exactly same as x of t. We are trying to express x of t in terms of sine t. Right? So this is equal to sine t into u of t minus pi. So sine t into u of t Laplace transform we know. Yes, we know the Laplace transform of sine t into u of t. But it is looking like sine t into u of t minus pi. So what I'll do is, okay, fine, sine t into u of t minus pi. Let me take a new slide. It will not be sufficient, it will become clumsy. Right, so let me take this x of t, the next slide as well. We have figured out x of t can be expressed as sine t into u of t minus, sorry, u of t minus pi minus u of t minus 2 pi. We can write like this, right? So what we know is sine t into u of t, sar sine omega naught t into u of t Laplace transform is, let me write the general formula that we've derived, sine omega naught t into u of t. It is omega naught by s square plus omega naught square, where the ROC is a real part of s greater than real part of the pole, which is 0. So this is the formula that we know. But here some time shifting is also happening. If time shifting is there, if the time shifting is there in both the places, wherever t is there, if it is shifted by t naught seconds, then we can apply the time shifting property. If shifting is happening in only one place, then we cannot apply the time shifting property. Right? So the answer would be e power minus st naught into omega naught by same Laplace transform, but it is multiplied with e power minus st naught. So what happens to the ROC? ROC generally should not change. Real part of s greater than 0, assuming t naught is positive, this becomes infinity when for any s equal to minus infinity. So s equal to minus infinity becomes the pole if t naught is positive, and s equal to minus infinity should not be part of the ROC. It is not anyway part of the ROC. We don't need to remove it separately. Right. So it should be in this format to write the Laplace transform easily. Right. So what we will do is, let us sine t into u of t minus pi minus sine t into u of t minus 2. So it is not in the standard format that we can write the formula easily. So let us convert it into a format that will be more comfortable for us to find the Laplace transform. So what I'll do is, I'll write as sin t is there. What we are expecting is sin t minus pi. What is sin t minus pi? Sin t minus pi is minus sin t. So sin t and sin of t minus pi, the relation is minus relation. So if you want, you can apply the basics of trigonometry. Sin of t minus pi is minus sin t. Minus into minus becomes plus sin. Yes, this is exactly same as sin t. We are not changing the equation. We're just modifying it so that we express it in the required format. Next, here we want t minus 2 pi. Yes, there is nothing wrong in writing sin t as sin of t minus 2 pi, because sin of t minus 2 pi is same as sin t, which is equal to, so the Laplace transform on both sides, if you take Laplace transform of this signal is minus into e power minus st naught s pi divided by s square plus here omega naught is 1, s square plus 1 square into 1 okay, minus again minus here. So same formula here, in place of t naught it is 2 pi, for minus s2 pi divided by s square plus 1 square into 1. Okay, fine, we got the answer. So it's minus e power minus s pi, if you take common it will be 1 plus e power minus s pi divided by s square plus 1, and the answer is finally, so this is the answer. In place of x of s we got something, let us substitute that there. Finally the answer is f of s, f of s, sorry, yeah, f of s, Laplace transform, what we want is f of s, capital F of s is equal to x of s into 1 by 1 minus e power minus 2 pi. So let us write that in the next slide. I've just copied that in the next slide. So this is equal to x of s, we already know, it is e power minus s pi minus n extra into 1 plus e power minus s pi divided by s square plus 1 into 1 divided by 1 minus e power minus 2 pi s. 1 divided by 1 minus e power minus 2 pi s, can we write this as 1 minus e power minus pi s into 1 plus e power minus pi s. Is that okay? 1 minus a into 1 plus a is 1 minus a square. If you express it that way, then there will some cancellation will happen, right? This term and this term gets cancelled. So finally the answer is e power minus s pi divided by s square plus 1 into 1 minus e power minus pi s. Yes, we got the answer. That is the answer. So fill in the blanks. When these days in GATE exam they are not going to give this kind of questions, because numerical answer type questions, they'll give a question, this kind of questions they can give, but they'll not ask us to fill the blank with this kind of result. They'll ask us to find the blank with some numerical result. Okay, so yeah, since it is 93 question, in those days this is like 25 yeah, 25 more 27 years old question. In those days I think that they used to give questions where we can write the total answer also, not just numerical answer type question, but the format has changed long back. Yeah, but this is the answer. If it is present day question, what they would have asked is find the Laplace transform at some s equal to 0 or s equal to 1, something like that. So to this answer on the same question they can ask, but they'll expect uh, the answer at some value of s, something like that. So they'll ask a question which will be some numerical value based on this result. Fine. So like this you can solve the question. So we have done in this today's class, we have revised some properties based on which we have done some problems on Laplace transform. We have found Laplace transform of some signals, and we found Laplace transform of signals which are repeating only for positive time. Okay, right. So I think we have almost done, we have almost covered almost all the types of problems of finding Laplace transform using properties. We have talked about ROCs. Yeah, we have talked about pretty much everything about finding Laplace transform of signals. In the next classes, we'll talk about inverse Laplace transform, and we'll talk about unilateral Laplace transform, and then we'll talk about if differential equations are given, how to deal with those kind of problems. So the remaining models of problems we'll deal with them in the next few parts, or in the series of Laplace transform classes. We'll discuss these remaining topics in the next parts. Okay. So that's it from my side for regarding the Laplace transforms that I wanted to discuss in this part. So just give me some time. Yeah. So if at all, if you're interested to learn from us the complete course, if you're interested to learn, then yeah, this is my profile. So I teach signals and systems and communication systems in the best way possible. And my master's itself is in communications. I'm a past out of IIT Madras. I've cracked GATE multiple times. And yeah, so this is my profile on Unacademy page. So you can follow me on Unacademy. So if you don't have an Academy app, you can install it and you can follow me on Unacademy page. If you follow me on Unacademy page, you'll get updates on my special classes, the free classes that I take, and the paid classes or the regular courses that I take. Whenever I start them, you'll get messages to your mobile phone. So you can follow me on this page. And so what means there is a concept of subscription on Unacademy platform. So if you want to attend the paid classes, which means the complete courses, live courses, so you can take subscription. So if you take subscription, you are not only eligible to attend my classes alone, you can attend the classes of all the expert faculty available on the platform. So I'm just showing you some names here. These are the faculties that will be teaching on Ignite batch. So not only these faculties, there are many other extraordinary teachers available on the platform. So once you take subscription for Unacademy platform, you will be eligible to attend the classes of each and every faculty available on the platform. You can see amazing faculties are available, amazing faculties, extraordinary faculties are available, right? So once you take subscription, you'll be eligible to attend each and every faculty's class on Unacademy platform for GATE and ESE category. And so you'll also be eligible to attend all the recorded classes also. So we don't specifically record the classes, but whatever live classes we take, every live class will be recorded. So for any chance, by any chance, if you miss the live class, you can watch the recording. Or if you have attended the live class, but still there is some confusion, then also you can watch the recording. And you can watch, there is no limitation on how many times you can watch the recording or how many faculties you can watch for the same subject. So for the same subject, there will be multiple faculties available on the platform. You can watch the lectures of each and every faculty. So humongous, lots and lots of advantages of Unacademy Plus subscription. So if you are really serious aspirant, then definitely this subscription will help you a lot. Yeah. So the most important part is the economics, the fees part. So the subscription for 1 year is just 25,000, and amazing teachers are available on the platform. So the quality of teaching will be much better than the best offline coaching centers in the country, much better. But the fees that the Unacademy is charging is 1/3 or 1/4 of the fees that the best offline coaching centers are charging. Very less fees and extraordinary quality. And one more thing is, you can subscribe for lesser number of months also. For 1 month also you can subscribe by paying less amount of fees also. So based on your situation, like if your preparation is almost over and if you're looking for a few subjects preparation from us, then you can subscribe for lesser number of months, maybe 1 or 2, 3 months. Or if you're looking for a total preparation, then go for 12 months or 24 months. So the more the number of months, the fees will be less actually. So you can plan accordingly. So when you are taking subscription, don't forget to use this code. This is my name and my code itself. This is a referral code. So once you use this code and you can, if you press the apply button, then your fees will be further discounted. Already fees is less and it will be further discounted if you use this code. Okay, so don't forget to use this code if at all, if you are taking a subscription in any future point of time. Okay, fine. So yeah, one last thing. So this is my Telegram ID, personal Telegram ID. You can contact me on this Telegram ID if you have any queries regarding anything. And if you have any queries on my subjects, my expertise subjects, signals and communications, this is the group that I'm maintaining on Telegram. So you can post any question, any doubts that you have on signals and communications in this group. Okay, and I'm starting a new communication batch on 26th of this month, 26th of June 2020. So if you are interested to attend my communications classes regularly, live classes, then you can take subscription and attend my classes starting from 26th of June 2020. Right? And don't forget to use this code if at all, if you're taking subscription. Okay? Any doubts, you can contact me. These are my contact details.